Welcome back to CarWow 787, the place where aviation power meets precision engineering. If you're passionate about flight, technology, and the machines that keep the skies alive, you're in the right place. Make sure to subscribe and hit the bell icon so you never miss our weekly breakdowns of aviation's most fascinating innovations. Today, we're taking a deep look at one of the most anticipated, powerful, and advanced turbofan engines in development, the GE TF90X. It's not just an engine, it's a glimpse into the future of high-performance aerospace propulsion. Whether it's powering the next generation of military aircraft, hypersonic systems, or long-range transport jets, the TF90X represents the cutting edge of what's possible when aerodynamics, thermal efficiency, and digital intelligence come together. Let's start at the core literally. The heart of the TF90X is its high-pressure core, built for unprecedented combustion temperatures, advanced fuel efficiency, and power-to-weight optimization. This engine is expected to operate at pressures well beyond 60 to 1, allowing it to burn fuel with maximum efficiency while maintaining lower emissions and reduced thermal signatures. That's a massive leap compared to traditional engines, and it means more thrust, lower fuel burn, and longer range. One of the key breakthroughs in the TF90X is its use of ceramic matrix composite CMCs. These materials are lighter and can withstand temperatures hundreds of degrees hotter than metal alloys. That allows the engine to run hotter and faster without compromising on durability or safety. These CMC components are used in the turbine blades, shrouds, and nozzles, reducing weight while increasing strength and thermal performance. To manage airflow, the TF90X uses a next-gen axial compressor design with up to 10 stages of compression. Each blade is crafted with 3D-printed titanium and carbon fiber blends, reducing drag and improving overall airflow stability. The fan blades up front are larger but lighter, using carbon fiber composite with a titanium leading edge. This combination allows the engine to suck in more air without adding unnecessary mass, which directly translates into greater thrust at lower fuel costs. The fan diameter is one of the largest in its class, but what makes it even more efficient is the high bypass ratio, likely above 12 to 1, which means more air bypasses the core than goes through it. This not only improves fuel economy but also reduces engine noise. For long-range missions and commercial application, that means quieter cabins and lower environmental impact. When it comes to digital capability, the TF90X is a leap ahead. It's fully integrated with GE's digital engine monitoring suite, using onboard sensors that feed real-time data to the aircraft systems and ground-based AI. From vibration analysis and blade stress to thermal hotspots and pressure differentials, the engine monitors its own health, performance, and maintenance needs on the fly. This means fewer surprise breakdowns, longer intervals between overhauls, and smarter fleet management. In terms of thrust, the TF90X is projected to produce well above 110,000 pounds of thrust. That puts it in a similar category to the GE9X, but designed for faster, more agile aircraft. This kind of power could support high-altitude, high-speed military missions or ultra-long-haul commercial flights. It's not just about speed, it's about sustained efficiency across altitudes and flight conditions, whether you're cruising at Mach 0.9 or climbing through turbulent airspace. Another critical innovation is in the engine's fuel system. The TF90X is designed with future aviation fuels in mind, including synthetic jet fuel, bio-blends, and even hydrogen-compatible variants in development. GE's engineers have prioritized environmental adaptability, knowing that fuel flexibility will be essential as the aviation world transitions toward net-zero emissions goals. Cooling is another aspect where this engine breaks new ground. With temperatures exceeding previous design limits, traditional air cooling wouldn't cut it. So the TF90X includes a multi-loop, adaptive cooling system that uses both air and fuel as heat sinks, dynamically adjusting flow based on engine stress and altitude. It's like having a smart cooling brain built right into the core, keeping the turbine running at peak efficiency no matter the operating conditions. The gearbox architecture has also seen significant innovation. The TF90X incorporates a variable cycle mechanism that adapts its configuration based on flight mode, optimizing for takeoff, cruise, or combat maneuvering, if used in military aircraft. This adaptive thrust system allows it to shift from high-bypass fuel-saving operation to low-bypass, high-thrust mode when raw power is needed. Essentially, the engine transforms itself in mid-flight, offering unmatched versatility. Noise is another area where the TF90X sets new standards. With advanced nacelle design, chevrons at the exhaust, and acoustic liners made with nano-structured materials, it achieves significant noise reduction. For urban airports, night flights, and stealth-oriented missions, this quieter operation opens up a new range of deployment options. From a maintenance standpoint, GE is designing the TF90X to be modular. That means faster part replacement, easier diagnostics, and less time on the ground. Technicians can swap out components with minimal disassembly, thanks to smart placement and self-aligning mechanisms. The goal is simple: reduce downtime, increase availability, and maximize lifecycle performance. It's also important to consider that the TF90X isn't being developed in isolation. It's part of GE's long-term roadmap for propulsion dominance, aligned with projects like the Next Generation Adaptive Propulsion Program and future commercial power plants. It builds on decades of experience from engines like the GE90, LEAP, and GE9X, but it's not just an upgrade, it's a redesign from the ground up with the next 30 years in mind. Safety remains a top priority, and the TF90X incorporates redundant systems for fuel control, ignition, and electrical generation. In the rare event of a malfunction, it can isolate problems and reroute resources to maintain thrust and control. GE's engineers have simulated extreme flight conditions from bird strikes and lightning to volcanic ash and high-altitude icing to ensure the engine survives and recovers under nearly all imaginable scenarios. We are also seeing a shift in how engines are tested. The TF90X is part of a new digital twin testing system. Before the physical engine is even built, GE creates a real-time, fully interactive virtual engine that's run through thousands of scenarios in simulation. That saves time, reduces cost, and allows the company to optimize performance before a single bolt is turned in the real world. Looking forward, the TF90X is more than just a powerhouse for one aircraft. It represents a flexible platform that can be scaled up or down, adapted for different aircraft configurations, and integrated with hybrid electric systems in the future. It's part of a broader strategy to push the envelope of sustainable, high-performance aviation. In short, the GE TF90X engine is not just about more power or more speed. It's about smarter engineering, lighter materials, adaptive control, fuel versatility, and a digital nervous system that makes it not just an engine, but an intelligent partner in flight. Whether you're an aviation enthusiast, an engineer, or just someone who loves the science behind flight, the TF90X is an engine worth watching. It's a symbol of what's coming next in the skies: faster, quieter, cleaner, and smarter machines that will define the next era of aviation. That wraps up our deep dive into the GE TF90X engine. If you enjoyed this breakdown and want to stay ahead of the curve on aerospace technology, make sure to like this video and hit the subscribe button. We bring you powerful content every week, from propulsion to pilots, and everything in between.